Hi students, welcome to today's class. Today I am going to take the topic that is sandwich theorem or skews theorem and the problems based on that. Okay, now let us see this sandwich theorem. Actually this theorem was defined by, previously it was Archimedes who gave an idea about this sandwich theorem, but in present thing, it is a Carl Friedrich Gauss. He was the mathematician Carl Friedrich Gauss. Carl Friedrich Gauss. Carl Friedrich Gauss, the mathematician, he was introduced to this sandwich theorem. What is sandwich theorem? For example, limit extends to a f of x. One function is there. It is difficult to find out the limit extends to a f of x, the function, the limit of the function f of x as extends to a. It is somewhat difficult, or it limit exists, but it exists, may not exist. If it is difficult to find out the limit extends to a f of x. Now, if you are able to find the functions which are of the form some g of x less than or equal to f of x less than or equal to h of x. That means, let us define two functions. Let us take two functions which lies, the function should lie, f of x should lie between g of x and h of x. Okay, we can call it as upper bound and lower bound, like that. If you are able to find out two functions which are above the function h of x and below the function g of x, then the limit extends to a g of x is less than or equal to limit extends to a f of x less than or equal to limit extends to a h of x. This gives the idea of the sandwich theorem. Okay, now let us define what is actually sandwich theorem. Okay, now let us see this. First idea is, let us take two functions f of x, g of x. They are real valued functions having the same domain, both functions, both f of x and g of x defined on the same domain. And if it is f of x is less than or equal to g of x, f of x is less than or equal to g of x for all x belongs to domain of the functions f and g. For all the x belongs to domain of the function, for all. So, we are saying that for both f of x and g of x, both domains are same. Whatever may be the number you substitute here, always f of x is less than or equal to g of x. Let us diagrammatically, let us take this is equal to f of x. It is always less than or equal to g of x. Sometimes it may be equal. So, this is g of x. F of x always less than or equal to g of x. Then there exist two things we are can conclude from this sandwich theorem. The first thing is, limit extends to a f of x is exist. If it is exist, and limit extends to a g of x is also exist. Both limits should be exist as extends to a. And if they are equal, therefore then exist, then always limit extends to a f of x is less than or equal to limit extends to a g of x. So, if both the limits exist, then only the limit value of limit extends to f of x is always less than or equal to limit extends to a g of x. This limit value is less than this limit value. Okay, now. So, when f of x is less than or equal to g of x, this is a first form of the sandwich theorem. We've taken two functions. If you take three functions, then see what happens. Okay, now. So, let us carry forward this same concept for three functions. Okay, afterwards 4 functions, afterwards n number of functions. Okay, So let us continue the concept. Hi students, welcome back to this sandwich theorem in a somewhat extended way, somewhat extended way. Let us take the three functions f of x, g of x, h of x. They are real valued functions defined on the same domain, f of x, g of x, h of x, all these functions defined on the same domain. For these functions, all these three functions, domain is same. Let us say that graphically I will show you. So f of x is, that means f of x is less than or equal to g of x is less than or equal to h of x for all x belongs to domain of f, g, h. For all x belongs to. So if you see the diagrammatically, so this is a one function, this is another function, this is another function. So this is called, this is f of x, g of x, this is h of x. See here, f of x is less than, g of x is less than h of x for certain values, some certain values this may be equal, f of x is equal to g of x is equal to h of x, sometimes for some x value belongs to the domain, but it is always f of x is less than, g of x is less than h of x, for some certain value it may be equal. Then if first thing, limit extends to a, f of x exists and its value is L, and the limit extends to a and h of x value is also exist and its value is L, then only both have the same limit. If it is, if only we are telling if, there is no rule that both should have the same limits. If it have, then according to the sandwich theorem, what is the center function? Limit extends to a, g of x is also L. Limit extends to a, g of x is equal to also, the center limit is also exist. And according to the previous concept, this also follows, that is a limit extends to a, f of x less than or equal to limit extends to a, g of x less than or equal to limit extends to a, h of x. If it is a less than concept, if you take, we will take that less than, the limit values also will become in increasing order. Okay, now right. Now here the very important thing that you have to remember is, as limit extends to a, f of x, there is no need of f of a should be less than, g of a should be less than h of a. It is no need of that. Even there is no need of f of a is equal to g of a is equal to h of a. No need of that. As means if you substitute x is equal to a, the output will be f of a, here g of a, here h of a will be the output for limit function. There is no need of f of a less than or equal to g of a less than or equal to h of a. Even f of a is equal to g of h is equal to h of a, no need. Why? Because here we are seeing the limit of this function as x approaches to a. As x approaches to a, then the value is limit. At exactly x is equal to a, the functional value may not be equal to L. The functional value may not be equal to L, may be equal to L. That's why even though this condition holds or does not holds, this theorem is holds. Okay now. So this is a very important, you have to remember that. Okay now. So I hope that you understand this sandwich theorem. As proof is also there. So but we don't take the proof here at this stage. We will take make use of the result only. Okay now, right. So I hope that you understand this sandwich theorem concept. Let us do some problems based on this theorem. Okay now. Hi students, welcome to this very simple problem. In the neighborhood of x is equal to 0, neighborhood means, so if you see here, don't get confused here, if it is C, this will be the neighborhood, understand? So neighborhood means a nearby values, nearby x is equal to 0 values, Okay, now that in that interval, very, very small interval, it is known 1 plus mod x is less than e power x minus 1 upon x less than 1 minus mod x, then find limit extends to 0 e power x minus 1 upon x. So actually speaking, directly you can do this problem limit extends to 0 e power x minus 1 by x by taking the L'Hospital rule. You can do that, but according to the given data, let us prove it. So here there are three functions are there, f of x less than g of x less than h of x. So let us apply limit extends to 0 on either side. So this is equal to limit extends to 0 1 plus mod x less than limit extends to 0 e power x by x less than limit extends to 0 1 minus mod x. Okay. As x tends to 0, we know that this is a 1 plus limit extends to 0 mod x. Here both left hand side limit, right hand side limit, both is equal to 0 plus less than limit extends to 0 e power x minus x less than limit x. So this is equal to 1 minus 0. So this is also 1, this is also 1. So according to the sandwich theorem, limit extends to 0 e power x minus 1 by x value is equal to 1. How much? So this is a way of finding this problem according to the sandwich theorem. So without sandwich theorem also we can do that. So just by taking the differentiation, e power x differentiation is 1, x differentiation 1, e power 0 is equal to 1, e power 0 is equal to 1. So like that also we can do. Okay, so I hope that you understand this problem. So let us do some more typical problems. Okay, hi students, welcome to this problem. Here f is a function from domain 1 comma 2 to R satisfying the inequality. So there is one inequality less than. What is that? So the function f of x lies between two functions. They are cos of 2x minus 4 minus 33 by 2. Here another function x square modulus of 4x minus 8 by x minus 2. Then for all x belongs to 1 comma 2. 1 comma 2 here it is domain. For all domains, so from 1 to 2, whatever may be the number, so infinite number of real numbers are there except 1 and 2. So whatever may be the number you substitute here, so the function f of x lies between this function and this function. Now we have to find out the limit extends to 2 minus, see here 2 minus means here we are approaching the function, here we are taking 1 and 2 domain. Limit extends to 2 minus means what? So we are approaching x2 from left side. So if it is from right side, we cannot define. Why? Because the function is not defined like that. Okay, right. Why? Because the domain is from 1 to 2 only. So then we have to define from x from left side only. So from 2 left side only, right? So what shall we do? So we will do apply the limit extends to 2 minus on either side. See the solution. So limit extends to 2 minus, so this is equal to cos of 2x minus 4 minus 33 upon 2 less than f of x less than limit extends to 2 minus x square modulus of 4x minus 8 by x minus 2. See here this problem, so here this we can calculate very nicely, no problem. X tends to 2 minus, x tends to 2 minus means what? Substitute here 2 2s are 4, 4 minus 4 0, cos 0 1, 1 minus 33, so this is a minus 32, minus 32 by 2 is equal to how much? Minus 16, less than f x less than, see here as the limit extends to 2 minus, then what will be the value of modulus of 4x minus h? See here, x tends to 2 minus means what? X value less than 2. X value less than 2. Therefore, 4x minus 4x is less than 4x is less than 8. 4x is less than, I am multiplying 4. 4x minus 8 is less than 0. So I am subtracting 8 on both sides. So 4x minus 8 less than 0 means what? Modulus of 4x minus 8 will be 8 minus 4x. So mod x is, when x less than 0, mod x is equal to minus x. So here it will take the form. So of course here So we are applied limit extends to 2 minus. So this is a limit extends to 2 minus. So here one more step I am writing 2 minus x square into, so this is equal to 8 minus 4x by x minus 2. 8 minus 4x by x minus 2. So this is equal to limit extends to 2 minus x square. Take 4 common. So if you take a 4 common, what happens here? So this is equal to 2 minus x. 2 minus x by x minus 2. This 2 minus x minus 2 can be cancelled. Of course, minus will come. Substitute x is equal to 2. 2 square 4. 4 4s are 16. So this is equal to minus 16. So here also minus 16. So here also minus 16. Therefore, the value of this limit extends to 2 minus f of x is equal to how much? Minus 16. Okay now. So I hope that you understand this solution. Let us move to one more problem. Hi students, welcome to this problem. If x square plus x minus 2 upon x plus 3 is less than or equal to f of x upon x square less than or equal to x square plus 2x minus 2 by x plus 3 holds for a certain interval containing the point x is equal to minus 1. That means in that interval minus 1 point is there and limit extends to minus 1 f of x exists. It is given that limit extends to minus 1 at x is equal to minus 1. The limit function is exist. Then find the value of limit extends to 1 f of x. See here, remember here in the central function is our function is f of x by x square, not simply f of x. Then how to find out this value? Okay na? So let us move as usual. How we will do is for a sandwich theorem. Let us move. So limit extends to minus 1. Let us substitute limit extends to minus 1. So apply limit extends to minus 1 on either side. So this is equal to limit extends to minus 1 x square plus x minus 2 upon x plus 3 less than or equal to limit extends to minus 1 f of x by x square less than or equal to limit extends to minus 1 x square plus 2x minus 2 upon x plus 3. Okay now, right. So just we applied limit extends to minus 1 on either side of that inequality. Now let us find out this value. So as x tends to minus 1, so this value we will see here. So this is equal to 1, this is a minus 1 minus 2 by, so this is a minus 1 plus 3. So this 2 will be get cancelled, minus 2 by 2, so this is equal to minus 1. Once you check here, it is the value minus 1. So substitute here x is equal to 1 means 1, this is a minus 2, this is a minus 1. This is a minus 1 plus 3. So here these 2 will get cancelled, minus 2 by 2 minus 1. Okay now. So here see here the left hand side you got minus 1 as a limit value. Right hand side also you got a limit value. By sandwich theorem we have limit extends to minus 1 f of x by x square is equal to minus 1. But we want limit extends to minus 1 f of x only, but not by x square. Then we will apply the properties of limits. So we can apply this limit to for both numerator and denominator. So that is equal to limit extends to minus 1 f of x by limit extends to minus 1 x square is equal to minus 1. Limit extends to minus 1 x square, wherever x is there, substitute minus 1 whole square means how much? 1. Do the cross multiplication. So limit extends to minus 1 f of x is equal to 1. Understand? Limit extends to minus 1 f of x is equal to 1. Okay, right. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. It is given that 0 less than log x to the base e less than root x for all x greater than 1. Then find the value of limit extends to infinity log x to the base e by x. Here the center function is not log x to the base e by x. Okay now. So observe that. So see the solution. What is given? 0 less than log x to the base e less than root x. What we want? Log x to the base e by x. So you can divide with x. Why? Because here x is greater than 1. X is a positive number. Therefore, you can divide with the x, no problem. 0 by x is equal to 0 less than x to the base e by x less than root x by x, nothing but 1 by root x. Root x by x is nothing but 1 by root x. Okay, na? 1 by root x. Now apply limit extends to infinity on either side. So this is equal to limit extends to infinity 0 less than limit extends to infinity log x by x less than limit extends to infinity 1 by root x. So this is a 0, this is also 0. As extends to infinity, see the denominator is going on increasing. Therefore, total the fraction will increasing, tends to 0. Therefore, finally, limit extends to infinity log x by x value is equal to 0. Okay, now. So, very nice problem this is so I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. If modulus of f of x is less than or equal to x square, then find the value of limit extends to 0 f of x by x. Then how to do this problem? Modulus of f of x is less than or equal to x square, then find the value of limit extends to 0 f of x by x. F of x by x you want, by x you want. Understand this? Okay. Then how to proceed means here solution. Modulus of f of x is less than or equal to x square. See here, x square can be written as mod x whole square. No problem. So this is equal to modulus of x whole square. So modulus of x whole square means what? Mod x into mod x. Bring one mod x to this side. This is f of x by x less than or equal to mod x. So mod x whole square means mod x into mod x. Let us bring one mod x here. So both mod x. Now apply limit extends to 0 on both sides. So this is equal to limit extends to 0 modulus of f of x by x less than or equal to limit extends to 0 modulus of x. So we have the property, so we can take the modulus outside, that is a modulus of limit extends to 0 f of x by x is less than or equal to, its value is 0, mod x mod 0 0, right. So the modulus value can never be negative, less than or equal to 0 is saying it never be negative. Therefore, limit extends to 0 f of x by x is equal to 0. So limit extends to 0 f of x by x is equal to 0. Okay, now. So if mod x is equal to 0, then x is equal to 0. So therefore, f of x by x value is 0. So its value is 0. Understand? So I hope that you understand this solution, and I hope that you enjoyed today's class with some more very important models which are very useful for your JEE mains examinations. So I will stand before you in tomorrow's class. Until then, all the best.